there is a circle exists, and then with the formula here you can get the center or radius in terms of c if you like. At this moment we only know that the center x coordinate is 3, while the y coordinate we do not know exactly. Afterward we have a straight line, and then for straight line to draw it we better change it to slope-intercept form. So y is equal to x plus 9. When x equals 0, y equal to 9. And then the slope is 1, so maybe it's like this. Now the P point is they intersect each other. That means fulfill the circle requirement, at the same time fulfill the straight line equation requirement. We concern about the point of intersection, which means the xy combination fulfill the first requirement, at the same time fulfill the second requirement. We are going to solve this simultaneous equation. And after that we'll get a quadratic equation, and then we know that there should be some solution. That means that we have some real roots here. Therefore, after we get, for example, like ax squared plus bx plus c equal to 0, we are going to claim that since there is some point of intersection, so the delta should be larger or equal to 0. Maybe there are 2 real roots, maybe there are 1 repeated real roots, but delta should be larger or equal to 0. It's give a constraint to this c here. Beware that this c is just from the equation, from the formula. It's not the same as here, this one. Anyway, if we have the restriction for c, then we can just solve the inequality, then we'll get one of these answers. So x squared plus something squared minus 6x plus c something minus 7 equal to 0. We just place x plus 9, and then we replace y here. Then we have an equation of x only with x squared here. So our target is something x squared plus something x plus something equals 0. I will suggest my student write in multiple row. So afterward we copy down negative 6x, which is the same column of x term here. And then we have plus cx plus 9c. And then we have minus 7, maybe I place here. So therefore 2x squared plus 12 plus c times of x. And then the constant is 9c plus 74. Just like what we concerned, we are not trying to get x. I'm not interested in the position of x. I just concerned about the constraint is delta is larger or equal to 0, because we have some intersection. So we have something squared minus 4 something something larger or equal to 0. B is 12 plus c. A is 2 while c is 9c plus 74. So we have a quadratic inequality. We are going to expand it. C squared plus 24c plus 144. And then minus a times this item minus 72c. So combine like terms. Of course, we are going to factorize it or use calculator as you like. To solve this inequality, we know that this is our open upward shape. And then with 2 real roots here, when it is equal to 0, then we know that we have the first roots negative 8 and also 56. This is different value of c. So we are searching what is the input of c such that the results will be larger than 0, such that the height here will be larger than 0. So we are talking about this section and also this section. Whenever c is less than negative 8, that means this side, then the input will be shown is upper, that means above the ground, fulfilling the requirement. So our favorable region is this region and also this region. Both fulfill our requirement. If c is within negative 8 and 56, it will cause 1 positive and 1 negative factor here and then become negative results. So you find that the height is below the ground. So this is not our target. Then we write down our target. C is less than equal to negative 8, or it can be larger or equal to 56. So therefore the answer is D.